In this webinar, we will cover securing the edge quickly and accurately, utilizing the Genians cybersecurity platform. Why is securing the edge important for your business? The edge is the focal point of IT investments and business productivity. Critical data is generated at the edge via various devices which are connected to the network. Major cybersecurity challenges are often present at the edge, and it is a lucrative target for hackers. Cybersecurity compliance and risk assessments often focus heavily on the edge, which makes it all that more critical. Genians is a company that provides multiple cybersecurity products. The main products include Genian NAC, Genian Device Platform Intelligence, and Genian Insights EDR. The company was established in 2005 and is publicly traded on the Korean stock market. There are over 140 employees, and the company is very heavily engineer focused. Genians has been providing cybersecurity solutions for over 16 years. Genians is number one in the South Korean market. Genians has over 30 global partners delivering its products and solutions. Genians and the global partners deliver these solutions to over 1,600 satisfied customers. Genians was named a representative vendor by both Frost & Sullivan and Gartner. Genians continues growing by providing successful cybersecurity solutions to its customers. Year over year, Genians has been able to grow with its customer base by providing these successful products and solutions, over doubling revenue in the last several years. These marquee customers are across every vertical market space, whether it be enterprise, financial, government and military, infrastructure and energy, healthcare, or education. Regardless of the size of the organization or what type of business, Genians has a cybersecurity product that will meet the needs of the business. Here you will see the basic security controls recommended by the Center for Internet Security. These basic controls, if implemented, can defeat over 85% of common attacks. Regardless of the regulatory compliance that governs your business or your customers' businesses, these controls meet the basic criteria for all of the different regulations. These controls, although basic in nature, are critical to any successful cybersecurity plan, and therefore should be the focus of all cybersecurity professionals working to certify their network or secure their customers' networks and protect them from vulnerabilities and attacks. Now let's review these common core cybersecurity requirements and correlate them to how Genian's cybersecurity platform can meet the requirement. Inventory and control of hardware assets. Genians can detect all IP-enabled devices on the network and correlate them to a specific platform. Inventory and control of software assets. Genians can inventory all installed software, including versions, on devices. Continuous vulnerability management. Genians provides an integrated CVE dashboard for all devices on the network and can also perform real-time quarantine. Controlled use of administrative privileges. Genians can authorize devices and users based on roles and responsibilities, and also provide least privilege access in the process. Secure configuration for hardware and software on mobile devices, laptops, and workstations. Genians can inspect detected devices' configuration and security settings and maintain a security baseline. Maintenance, monitoring, and analysis of audit logs. Genians can monitor access and security events, maintain logs for audit trail, and also send notifications to admins and external systems. Let's take a moment to talk about the building blocks for cybersecurity. What are the major components that are required for any successful cybersecurity strategy? Surveillance. You must find out what exists and what is happening on your network. Without a proper view of the landscape of the users, devices, and threats on your network, you cannot effectively plan a strategy. Therefore, visibility is key and should be considered the foundation of any cybersecurity strategy. Control. Once you have visibility of what is occurring on your network, you can then implement control policies. These will allow you to assess policy compliance of users and devices connecting to your network, control the network access to prevent unauthorized devices and users from connecting, and assign the appropriate privileges when users and devices do connect. Automation. Automation is critical to be able to automate the process of both quarantine and remediation when threats are presented on the network. Once you've implemented surveillance and control, automation is key because no one solution can fix all problems. Therefore, it is critical that solutions that are being implemented have the ability to integrate with other portions of the cybersecurity ecosystem. So how can the Genian cybersecurity platform enable the various building blocks we've discussed here? First, for surveillance, Genian Device Platform Intelligence can detect all IP-enabled devices on the network. It can then correlate these devices to specific platforms and provide critical metadata for each platform. It can do so in a non-intrusive manner, which is critical for sensitive network environments such as OT, where active or excessive scanning can cause problems for devices connected to the network. For control, Genian NAC can control what devices and users connect to your network and then assign the appropriate privileges when they connect. While Genian's Insights E, EDR, can detect and remediate in real time any threats on the network. For automation, there is a REST API provided for both Genian DPI and Genian NAC. This allows for bidirectional integration with external systems in the cybersecurity ecosystem to either provide information from Genians to external systems or feed information into Genian systems from other systems. This is critical to automate the process of quarantine, remediation, and notification. Genian Device Platform Intelligence, or GDPI, provides Visibility 2.0. This goes beyond legacy device fingerprinting. GDPI provides platform identity, context, and risk. It is hosted in a cloud database with an API that is also available as a subscription service. Over 6,000 new platforms were added in 2020 alone. Identity. A specific platform is assigned to each device that is detected. This includes manufacturer, connection types, an actual image of the device, along with additional information. Context. GDPI provides business information. This includes end of sale, end of life, and country of origin. This provides context for the information specific to the device. Risk. Technology vulnerability risks are also listed, including CVEs that are applicable for each platform. Business vulnerability is also listed. This includes if the business has gone out of business or has been acquired. All this information together allowed cybersecurity professionals to manage the risk of each device connected to their network. Let's examine two use cases where GDPI provides information above and beyond legacy device fingerprinting. First, we will work with EOL and EOS information. GDPI has the ability to group these devices together so network administrators can restrict access or perform other actions for any device that is end of life or end of sale on their network. First, we'll take a look at the legacy device fingerprinting approach. With legacy device fingerprinting, you get a general category for the device, such as printer, phone, computer, mobile device, etc. To get end of life or end of sale information, if at all possible, typically requires third-party integrations, most of the time specific to certain manufacturers. Then a VLAN is assigned, which doesn't provide any detailed restrictive action for the devices, and also it doesn't really follow the device around if it roams. This also requires network integration and integration with switches or wireless controllers and access points. GDPI with Genian NAC is different. GDPI provides information above and beyond general categories. Specific platforms are assigned to each device that connects to the network. Each platform that has EOS or EOL information is linked to the platform record. Those EOS EOL platforms can then be collected together and added to a group. That group can be added to an enforcement policy, and those devices can be restricted or denied network access, or network administrators can just be notified of their existence. The next use case we will examine is CVE information. GDPI provides the ability to restrict platforms that are correlated with specific CVEs. Let's compare and contrast this to the legacy fingerprinting approach. As we mentioned previously, legacy fingerprinting puts devices into general categories, not specific platforms. To obtain CVE information, third-party integration is typically required. This will also typically come with some type of cost associated with it. And of course, general network restrictions such as VLANs are assigned, and this requires complex integrations with the wired and wireless network. GDPI does not have any network integration requirements to correlate devices with CVEs and perform restrictive actions. First, the GDPI database contains specific platforms, so each device is assigned a specific platform. Then, that platform, if applicable, is linked to the specific CV information that may be applicable to that platform. Those platforms can then be added to groups, and then the groups are added to enforcement policies which may restrict or deny network access. Again, that is optional, and administrators could just notify themselves or send automated notifications to external systems like ServiceNow, Teams, or Slack. Let's take a closer look at the structure of GDPI. The GDPI database is split into two sections. First, there are regex-based detection rules. These rules can ingest raw scan information such as Nmap or other information, combine the information, and then using scoring mechanisms can assign a platform and a manufacturer based on the raw data. The second part of the database includes all of the extended metadata for the platforms and the manufacturer-specific information. This includes things such as the image of a device, end of sale, end of life information, CVE mapping, business status, etc. Consumers can actually access the GDPI database through the Cloud API. Typical subscribers are split up into two different categories. Detection database subscribers are typically customers that have raw information that they have obtained from scanning the network, but are not confident that they can accurately fingerprint or identify the platforms that they've detected. By subscribing to the regex-based detection rules, you can get accurate information based on what type of platform and the manufacturer for the devices that you have the raw data for. The second category of subscribers are the full database subscribers. These are typically customers that are confident they have accurately fingerprinted and know the platform and manufacturer of their devices, but want to augment those devices and that data with the extended database information and all of the specific metadata available for the platform and the manufacturer. This model also empowers MSPs because of the flexible subscription options as well as co-branding and white label options. GDPI is its own product, separate from NAC, and can be consumed as such through a subscription option. Genian NAC provides network access control in 3 easy steps. First, dynamic node grouping. Second, granular policy enforcement. And third, choosing your enforcement method. Genian NAC provides dynamic classification through over 500 predefined conditions to choose from, or you can create your own. You can then configure policy enforcement based on endpoint compliance status. Then granular permissions are assigned to any nodes matching on the policies. Genian NAC also provides multi-layered security and enforcement, meaning you can choose your enforcement mechanism. The Layer 2 ARP enforcement method is preferred by most of our customers because of its easy implementation and no requirement for complex network integrations. However, multiple enforcement options are provided in addition to this, including 802.1x via the built-in Radius server, span or mirror port enforcement, Inline Enforcer, which is a dual home gateway available for both on-prem and cloud deployments, an agent which can quarantine the device at the NIC level, and a built-in DHCP server. Let's briefly cover the Genian NAC system components. There are 3 primary components to the system. First, there is the policy server. The policy server is used for overall management of the system. It can be managed by a public, private, or hybrid cloud deployment. It can also be deployed on-prem, delivered in ISO image, and can be installed as a VM or on hardware. It correlates all of the data from all of the network sensors deployed throughout the customer network. The policy server includes policy configuration, distribution, and centralized logging and reporting. The next component is the network sensor. The network sensor provides both visibility and control without the requirement for any complex network integrations. It is also delivered as an ISO image and can also be installed as a VM or on hardware. It can be installed on small form factor hardware such as Intel NUC, Mini PC, or even Raspberry Pi. There is no integration required with the network. It is non-intrusive and has a fail-safe option. The final component is the agent. The agent is optional and is used for endpoint visibility and control. Endpoint visibility, security policies, and control collect hardware, software, and user information. It also provides 802.1x and WPA2E auto provisioning of an endpoint, and it can monitor and prohibit ports and applications. There is also a sensor plugin option available that allows an endpoint to act as a sensor to detect nodes on its subnet. Genian NAC can be rapidly deployed using ARP enforcement to block unknown devices by default. First, a policy server is deployed. It can be deployed either on-prem or in the cloud. Cloud options include the Genians Managed Cloud or a cloud policy server that can be obtained from the AWS Marketplace and installed on a customer virtual private cloud. The system can be configured to block new devices that are not explicitly trusted. This follows the best practices of the Zero Trust model. No edge switch controller or AP configuration is required. High availability is also not required because the system fails open. The system is truly vendor agnostic, no network dependencies. It can be rapidly deployed in approximately 10 minutes for policy server and sensor, and it supports virtual environments. Once the policy server is deployed, network sensors can then be deployed at various locations in the network depending on the network topology. Network sensors will automatically detect new devices, and any new device that is not explicitly trusted will be blocked by default at its point of connection using ARP enforcement, which again requires no complex network integrations and is suitable for all network environments. Genian NAC can also be configured to provide logical segmentation on any network. This allows network administrators to assign least privilege access to trusted devices, which is part of the Zero Trust model and a best practice. This can be achieved without any complex network integrations. The permissions will follow the device or the user, which is much easier to manage than static network configurations. This is accomplished by defining separate permissions, which will then logically carve out what access each device has while it is connected. You can provide trusted or full access, guest access for internet only, or even some limited internal access only for IoT and OT environments. These are just a few examples, but obviously multiple different permissions can be configured to meet your specific use case. Let's review how you can quickly and easily in a few minutes provide segmentation with Genian NAC ARP enforcement. Step 1 is to define node tags. This allows you to tag specific devices and designate them for certain uses. For example, you could have an employee tag, a guest tag, and some other limited tag. Once you define the tags, you can create node groups. Node groups will match on the previously created tags to group nodes together as they connect to the network. The node groups can then be linked to enforcement policies and permissions. This means that any device that is assigned a tag, matches a group, then falls under the enforcement policy and automatically has the defined permissions applied to the device. You can test and validate to ensure the tagging, the groups, and the enforcement policies work. The important item to remember here is this does not require any network integration and is all defined in software inside of Genian NAC. This means no matter where the device travels to, different floor, different building, different campus, wired or wireless, these permissions will follow the device, so the logical segmentation is always intact regardless of the network infrastructure or network upgrades and replacements. Let's take a moment to review least privilege access and segmentation and why it is so important. First, we'll take a look at legacy privilege access. Historically, access was defined by department or unit. That means that different departments and units would be assigned to a static VLAN on the network. Typically, what this means is anyone in a particular department has the same access as everyone else in the same department. What this means with legacy privilege access is that you have increased exposure and risk. That's because you have a larger attack surface. So if one single user is compromised, then the entire attack surface includes the entire VLAN that user is on. So regardless of where this user resides, if legacy privilege access is assigned, this gives this user and the user's device access to more information than required. So this does not follow least privilege access and creates a larger attack surface if there is a threat. Let's contrast legacy privilege access with least privilege access. Using least privilege access, unlike legacy privilege access, you have dynamic segregation by not only user, but device and compliance status as well. Using Genian NAC, there is no network dependency to perform this segregation. With least privilege access, instead of having access to an entire VLAN, an individual may have access only to one particular server, or maybe even a particular service on that server. With least privilege access, we have reduced exposure and risk. As we can see here, the potential attack surface if a single user or device is compromised has been reduced. Because the user and device did not have access to the entire VLAN, the attack surface is reduced only to the individual's device and then a particular server or even maybe a particular service on a particular server. This greatly reduces the attack surface and mitigates the overall risk and exposure for the network if there is a threat. Let's cover Genian NAC remote access enforcement options. Although there are a multitude of different use cases, we've selected 3 specific use cases here for demonstrative purposes. First, we will cover the unauthorized user use case. The Genian NAC policy server comes preloaded with a built-in radius server. This radius server can take in radius requests from a network access device which controls connections into the network at the network perimeter. The Genian NAC radius and policy server will then validate the credentials and then send a radius response back to the network access device. At that point, any user that does not have valid credentials will be denied network access. The next use case we will cover is 2 different compliant and authorized users who require different permissions. Here we will see compliant authorized user A. Based on various criteria that the system administrator can configure, including user ID, group, compliance status, or other information, this user can be granted different privileges than compliant authorized user B. When the radius request is sent to the network access device, the Genian NAC radius policy server replies back with an attribute. That attribute can be something like a downloadable ACL, which is applied to the network access device. This allows compliant authorized user A only access to server farm A. The same process happens when compliant authorized user B connects to the network. The policy server and radius server of Genian NAC returns an attribute such as a downloadable ACL, which is applied to the remote access session for user B, allowing user B only access to server farm B. Of course, more granular access can be permitted in the downloadable ACL, such as access to only an individual server or even an individual service on a server, but this is a basic example of how this feature can work. In the third use case, we have an authorized user that is non-compliant. The Genian NAC agent, which is installed, has actually determined that this is a non-compliant posture or an invalid posture for this endpoint. This could mean it has detected something like antivirus not installed or running or out of date, or perhaps there's an unauthorized or prohibited application that is running. These types of posture policies are important not only when employees are not in the office, but also when they are remotely connecting into the corporate network. Therefore, you want to ensure that you are validating the posture of any device that is connecting to the inside of the network. In this use case, the radius request would be sent and the device would actually be blocked from access because the agent had reported to the policy server that there's an invalid posture. Therefore, a reject is sent back and there is no access into the internal corporate network until the endpoint posture is changed and the user has remediated. Once the posture is valid, that user would then be able to connect just like any other compliant authorized user. As we have previously mentioned, security automation is one of the key building blocks for cybersecurity. Security automation allows for the automatic quarantine and remediation of devices, as well as the ability to notify or trigger other actions when an event occurs. This allows for system administrators to spend less time performing manual functions, while at the same time ensuring network security takes place in real time. First, there will be a system on the network that is part of the cybersecurity ecosystem, such as a next-gen firewall, IDS, or SIM, that is monitoring for threats. Once a threat is detected, that system can use either syslog or API to send the threats to Genian NAC. The Genian NAC policy server will then instruct the network sensors at various locations in the network to automatically quarantine whatever the offending device is in real time. The end user can then optionally see a captive portal to indicate that they've been quarantined for a threat. Next, an external alert will be sent out. These notifications can be sent out in various formats. For example, you can send email and SMS alerts to system administrators, but you can also use features like the webhook post to external systems such as Teams, Slack, or ServiceNow to notify those systems that a threat has been detected and quarantined in real time. This allows for coordination of remote users and administrators, but does not require any manual action on their part, but it can open tickets or create messages and channels to allow for better coordination and management of the overall network security. An important part of security automation is to allow external systems to communicate with each other. The Genian NAC REST API allows external systems to either perform actions or obtain information from the Genian NAC database. Here are some of the most common use cases for the Genian NAC REST API. Node information. External systems can list all nodes, add or delete nodes, update a node, retrieve node details, or deauthenticate a node. The same actions are available for a user. An external system can list all users, add or delete a user, update a user, reset a user password, or even generate a user one-time password. For node groups, external systems can list all node groups, add or delete, update node group, retrieve the conditions inside of a node group, or even update a condition inside of a node group. For policies, external systems can list policies, list the wireless LAN policies, apply a policy, list or create a network object inside of a policy, or update an existing network object. For CVEs, external systems are allowed to use the API to list all CVEs associated with the node. It can also search for CVEs related to a specific platform. And finally, for reporting, external systems can utilize the API to list reports, retrieve a specific report file, or retrieve report data. Let's take a moment to summarize all of the key features required to secure the edge. Among the critical features, we discussed visibility of all IP-enabled devices without disturbing existing IT operations. We also talked about contextual device platform intelligence. This allows you to have information that is much more detailed with critical metadata that is not provided with legacy device fingerprinting. We discussed the importance of zero trust, segmentation, and least privilege access, which is a best practice. We talked about abnormal traffic detection and quarantine in real time, utilizing security automation. Any solution you implement should be able to provide XBA through solutions such as EDR to detect and mitigate unknown threats. For edge environment support, we discussed pragmatic implementation options that allow visibility, enforcement, and automation. Contactless deployment options are important, especially now, and with Genian NAC, you have the ability to deploy virtual instances and sensors that require no network integration that allows for a completely remote deployment of the solution. Low complexity and seamless integration with third-party systems is also key to enable security automation. And finally, cloud management in public, private, or hybrid environments is important. So any solution you choose to secure your network environment should include these options. Thank you for attending today's overview of the Genians Cybersecurity Platform. For more information, visit www.genians.com.